So August 2017, we have number 13, very tricky problem. So what we have is when we rotate a rectangle, really depends on what we rotate it around. So let's say we were to have 6 this way, 10 this way, and we rotated this rectangle around that side. Okay, what would happen is this piece right here, this 6, would become our radius. And that's kind of what this question is about here. Okay. Now, if they give us the volume, what they're essentially telling us is, or they're asking us is, what did we rotate around? Was it one of the sides? Because, of course, if we spin it around, if we rotate around the 6, then we get a radius of, if you see this, we get a radius of 10, believe it or not. Okay, so if we rotate it around that, get a much bigger radius. So we could get a radius of 10, we could get a radius of 6. So we've got to test these until we figure out which one it is rotated around. And the only information I know is that we need 150 pi. Now the volume is calculated by multiplying pi times r squared times h. So if we simplify it a little bit, basically what we come down to is 150 pi equals pi r h. Sorry, I missed the pi. R squared h. The only thing we know is we can knock out the pi's. If we divide out pi, we're left with r squared times h is 150. So we got to mess around with this until we get r squared times h to be 150. Now, if we go with r being 10 and then h being 6, let's say we do that. If r is 10 and h is 6, we'd have 10 squared times 6, that's not 150. Okay, so the radius is not going to be 10. We did not rotate it around this side. Okay, however, if we rotated it around, say, the center of that, what would end up happening is now we get a radius of half of 10, which is 5, and then still a height of 6. So let's test that out. What's 5 squared times 6? It does equal 150. So what we'd have to do is understand that that is a vertical line of symmetry. This line right here that would cut it in half is a vertical line of symmetry. And that is the one we'd need, so that the radius would be 5 and the height would be 6. Tricky problem. All right, next. This is a problem we've seen a lot lately, and it's been troubling. What we've got to understand is, what are the properties of a parallelogram? What we have to understand is ABCD is already a parallelogram. It's got all of the properties that a parallelogram would have. Now we want to upgrade a parallelogram, meaning it would be increased special features so that we get a rhombus. Now, if we know we have a parallelogram already and we want to upgrade to a rhombus, what we would need is a couple of possibilities. All sides congruent. Since we already have a parallelogram, actually all you need is adjacent sides congruent. Because if you have a parallelogram, opposite sides are already congruent. It would be a matter of getting the adjacent sides congruent. Just one pair. Let's see. AC, the same as BD, is not a pair of sides. It's a diagonal. So, yeah, that's not right. All right, so that's not what I was hoping for. AC perpendicular to BD, that's the one. Okay, so to upgrade from a parallelogram to a rhombus, another option we have would be to get the diagonals perpendicular. And that's what this problem is about. Okay, so the other property to upgrade from a parallelogram to a rhombus is to get diagonals perpendicular. Okay. Now that does not have to happen in a parallelogram, but if it does happen, then we have a rhombus. So there it is. AC congruent, perpendicular to BD would get us a rhombus. Okay, number 15 is a trig problem, it looks like. Let's see here. 1 inch of vertical rise, and then horizontally would be 12 inches. Okay, so the units of measure are the same. That's important. What is the angle of inclination right there to the nearest hundredth of a degree? All right, here's what we would do. In a trig problem, I would label this hypotenuse compared to this angle. That leg's opposite, and this leg is adjacent. So then I would write in my trig functions, my acronym, and it looks to me like I'm going to use tangent. Okay? Now the ratio of the sides for tangent is opposite over adjacent. Okay? So what I'd like to do, and this is backwards, but we learn this, tangent of some unknown angle is going to give us opposite over adjacent, which would be 1 over 12 in this case. Now I would let my calculator do this. What we're used to is cross multiplying, but that is not the case here. We're looking for the angle, so we would change this to 0.83 repeating. Now this is the strange step. To get rid of tangent, you have to perform the inverse function for tangent, which is tan inverse. I know that seems a little strange. It's a brand new this year for you. Kind of algebraic procedure, right? So that tan inverse gets us an angle given the ratio of the two sides. Okay, so 0.083 repeating. Now your teacher might teach you to just put tan inverse of 1 divided by 12. Same difference. It just seems like I feel like my students do a little better with it this way. Now tan inverse knocks out tan, function tan, so then we get x in degrees. Let me go double check that. So I get 4.763, so that's the closest to that. Last one we'll do on this video. So midpoints, what this means is these are all the mid segments, these FE. So what I'm going to highlight right now is all the mid segments because mid segments join the midpoints. Okay, so this is our situation right here. What's the ratio of the areas, CFE, to the area of CAB? Okay. What you end up seeing here is there are, in fact, 4 congruent triangles. Okay. This one is half of the full side here and parallel to. This one is half of this side and parallel to. So what we end up with is 4 congruent triangles. So if they're all congruent and CFE is one of the 4, the area of CFE to the whole thing is 1 to 4. I know that seems strange. The sides are half, 1 to 2, but the areas are two-dimensional. 1 to 2 is the sides. Okay, 1 squared to 2 squared is going to be the areas. Okay, so that's 1 to 4. All right, a little strange. That'll be it for this video, and we'll pick up the next 6 questions or 8 questions on the next one.